Assalamualaikum. The topic for this presentation is about SCI, which is Stretchable Conductive Ink. We are from Group A6, which our group member is Muhammad Ali Zuhair, Muhammad Azhar Hakimi, Ahmad Muhammad Firdaus, Muhammad Nur Ahmad Zarif, Muhammad Haziq, and Muhammad Shafiq.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Hashim, and today I am going to talk about the project summary of this SCI assignment. So, stretchable conductive ink is a newly invented method of conducting electricity in circuit boards. There's many advantages of using SCI. Such of them are the appliance that uses SCI can be bent beyond normal circumstances. This is because they are highly flexible. Then, first of all, this project has chosen poly-3,4-ethylene dioxythiophene polystyrene sulfonate, or also known as PEDOT PSS, is the matrix material. This is because they possess a high conductivity, high electrochemical, and low redox potential. This material also acts as the ink for the SCI. Then, secondly, for the substrate material, Thermoplastic polyurethane, or also known as TPU, is chosen as the substrate material for the SCI. This is because TPU is a highly elastic, high-performance polymeric material with application in coatings, adhesives, reaction injection, and others. One of the main features of TPU is the ability to withstand elongation up to 700% of its original size. Then finally, for the filler material, graphene is used. This is because graphene has excellent properties such as, which is makes the best filler material. The impressive properties is it can be extended up to 20% of its original length.
Hi, I'm Ammar, and I want to present the definition of nanocomposite and its application. So, nanocomposites are material with at least 1 nanometer dimension. It demonstrates high-level performance, and composite combinations have unusual properties and uniqueness in design possibilities. So, they are made of two or more different composites with varying physical and chemical properties, and they usually have different phases separately by an interface. So, characteristic of nanoparticle, they have extremely high surface to volume and aspect ratios. They are ideal for use in polymeric material. These structures combine the best properties of each component in order to have enhanced mechanical and superconducting properties for an advanced application. So, mechanical properties such as strength, dimensional stability, thermal stability, and chemical resistance can be significantly improved by nanocomposites. As can be seen, the promising applications of nanocomposite systems are numerous, including the creation of new materials and the enhancement of the performance of existing devices such as fuel cell, sensors, and coatings. Although the use of nanocomposites in industry is not yet widespread, a massive transition from research to industry has already begun and is expected to be widespread in the coming years.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Shafiq and I will present about formulation. In this case, we use PEDOT as a polymer binder. In the first step, the PEDOT combination with 89.82% of weight concentration and all surfactant will be dissolved in a single container according to the table 1. We choose to use DMSO because DMSO is the main solvent to use to improve the layer conductivity. And next, we use monoethylene glycol because it contributes to the viscosity and surface tension of the ink. And lastly, Triton S100 we use to enhance the spreadability of PEDOT and as a stabilizing agent. For the conductive filler, we choose to use graphene nanoplatelet. It is because graphene nanoplatelets was used as a nanofiller particle to improve the characteristic of polymer composites such as thermal, electrical, and mechanical properties. And graphene is considered as a good electrical conductor. For the mixing process, the PEDOT process, solvent, and graphene are mixed together by using a machine. The parameter of speed and time was constant at 2000 rpm for 10 minutes. And for the printing process, SCI is printed using screen printing. Conductive ink is applied to a stencil on TPU. The stencil image was created by scraping the ink with the squeegees. And lastly, for the curing process, we cure the conductive ink at 60 degrees C for the 15 minutes. That's all from me. Thank you.
Okay, for the next part is testing for SCI. There are 4 tests that can be done to the SCI, which is first, torsion test, second, bending test, third, stretch test, fourth, hygrothermal test. For the torsion test, the procedure is firstly, torsional bending test is done by house-made testing system, which designed to conduct reliability test for electronic. Second, the SCI sample is clamped one end to the rotating motor and another end to a fixed position. Third, a strain gauge-based load cell is used to measure the tension applied to the sample during torsional bending. Fourth, the system control and procedure of measurement are operated by LabVIEW program, which used to measure conductor resistance motor with the data from load cell.
For the bend test, the digital multimeter was used to measure the resistance between the terminal. The bend test was set up by folding a sample in half with the print on the exterior and clamping one end to a table. 2 copper strips were linked to both terminals between the clamps and the sample, it forming a 4-point probe test similar to tensile test. Before beginning the test, the resistance was measured and compared to the resistance obtained with the digital multimeter. Then a steel rod with a diameter of 2 mm are put into the fold. The sample was then passed with a 13 mm rod by rolling it toward the 2 mm diameter bend. The sample will be bent at radius of 1 mm when the roller could no longer roll free. The pressure was released when the roller rolled back and the sample returned to a natural bend. The test will be conducted for 25 times with 5 seconds of pressure and without pressure.
Okay, now I will talk about manual stretch test. Step number 1, prepare the sample with fixed pin at one end and free pin on the other end. A ruler also is placed on the sample to get identical stretch force. Step number 2, the fixed clamp is placed with 2 glass slides to elevate while the other end is free, which force will be delivered for stretching. Step number 3, the resistivity was evaluated for every cycle until 20 cycles for the elongation using a multimeter. And lastly, step number 4, the surface morphology and resistance data were recorded every 5 cycles until 20 cycles of stretch test. Okay, for hygrothermal test, first, sample preparation begins with screen printing by using 4-point probe. Second, the sample was then placed into the curing oven with temperatures 100 degrees Celsius for 30 minutes and was taken out to cure for 24 hours at room temperature. For the hygrothermal aging test, the sample were placed at environmental chamber for 85 degrees Celsius and 85% relative humidity for 24 hours. And lastly, resistivity tests are then done for determination electrical conductivity of the ink.